Kia ora. Let's now practice looking at some infrared functional groups and working out which functional groups are present and which are absent. So pause each time, pause the video each time, have a look at this table that's on the right-hand side to help you, because this will also be given in the assessment task. So you can see where you would find, for instance, the carbon-hydrogen stretch, if it's attached to a carbon double bond. Just in case you forget, you don't have to learn those stretches off by heart. They are given over here. But remember, you do need to read them exactly where each peak is using the values on the x-axis. These are a little bit small, I know, but in the task you would have to do it. So I'll just go through, but I'll say each time, pause, have a look, see if you can work it out, and then we can go through the answer. So let's look at the first one. We only have this strong finger-like group over here at round about just 1730 roundabout. Nothing over here. We've got alkyl over here, and I'll explain that over here. And we've got nothing over here. So we don't have an ester, alcohol, amine, acyl chloride, amide. It's too high for an amide, too low for an acyl chloride. We don't have an alcohol, carboxylic acid, because there's nothing over here. Why can I say it's an aldehyde and not a ketone? And it's because of this W over here that is specific to an aldehyde and not to a ketone. So pause here, see if you can work out what number 2 is. And here's the answer. It's a carboxylic acid, because you see the strong, broad triangular peak based over the 3000 peak. And you've got it supported by the strong finger-like peak at around about 1700, 1720. And we know it's not an amine, alkene, acyl chloride, or amide, because it's too low for an acyl chloride, too high for an amide for this finger-like peak. We don't have any alkene peaks, although I must admit you can't see that one over there. Haloalkane, you could say, okay, there's a sort of peak over here, so it may have a chlorine in there. And you would have to look at other spectra to find out whether chlorine is present or not. So number 3, pause, see if you can work it out. Well, here's the answer. It's an amide. You can see it's not very clear, but there are 2 little peaks over there for the asymmetric and symmetric stretch. And this finger-like peak, it's not as strong as normal, but it's between the 16 and 1700, so it's below the 1700. So that would be an amide. It's not a carboxylic acid, ester, acyl chloride, haloalkane, and think of the reasons why. An alkene, it's a bit difficult to see because the alkene peak could be hidden over here, although normally it's sharp and narrow. An amine would have this peak over here, so it depends if this was an anomaly or not, and you would have supported with other evidence. So here, pause, see if you can work it out. Here's the answer. It's a ketone. You could say, well, that's perhaps a W, so you'd perhaps refer to other evidence and other spectra. This peak over here is often an anomaly, particularly in aldehydes, but sometimes in ketones, so just be aware of that. We know it's certainly not an alcohol, alkene, or acyl chloride, because this finger-like peak is too low for an acyl chloride. It's actually too high for an amide, so we know it's not an amide. And could possibly be an amine or an ester. We would look elsewhere to confirm that it's a ketone. So for number 2, pause. Hopefully you've worked it out, and hopefully you saw straight away this parabolic peak for the alcohol, and look at this little narrow peak over here for an alkene, and these other carbon-carbon alkene peak. So we know it's an alkene and an alcohol. There are 2 functional groups in this one. And you can go through all the ones that are not there. Number 3, pause. Can you work it out? Here's the answer. This is an aldehyde. It's got a clear W. As I say, there's not much difference between that one over there and this one over here, and you would look for supporting evidence elsewhere. And we know this is not an acyl chloride or an amide, because it's too high for an amide, too low for an acyl chloride. It's more or less where the carboxylic acid is. But the carboxylic acid, we know it's not that, because there's no broad triangular peak. And We know it's not an ester either because there are no strong narrow peaks here around about 1000 and 1100 centimeters to the -1. So for the last three, pause, work out. Let's have a look. Hopefully you saw this alkene peak. It's a bit hidden over there. Okay, but there's an alkene peak over here. It's not that strong finger-like peak. It's a narrow, a sharp peak. And we've got quite a lot of strong peaks in the fingerprint regions, which makes us suspect a chlorine or a halogen of some sort. So we would look elsewhere to confirm. And we would also look elsewhere to confirm that these are not the case. We know it's not an amine, we know it's not an amine because there's nothing here, and it's not an alcohol or carboxylic acid. And we know it's not an amide or an acyl chloride. And probably in not any carbonyl peak because it's just not that finger-like shape. For number two, pause, work it out, and hopefully you'll work out it's a haloalkane, although it won't be an ester because there's no sharp finger-like peak over here, or strong finger-like peak around about 1700, and we know it's not an alcohol or an amine, and it's not an alkene because of those missing peaks. And finally, number three, can you work it out? So here's the answer. In this case, it's an ester with a halogen. So there's lots of peaks over here from the chlorine. There's the CO stretch for the ester, and this is the strong carbonyl peak for the ester. But it's not, there's not anything over here, and there's no alkene. That's not narrow and sharp enough for an alkene over there. So have a systematic look through, say what's there and what's not there, and just keep on practicing, and these functional groups will just start leaping out at you. Kia ora.